Today we're going to learn about square roots. So if I had the square root of 25, what is that asking me to look for? The answer is certainly 5. What number times itself? So it's kind of like saying some number times itself equals 25. Or instead of times itself, we could say squared. What number squared equals 25? Does that make sense? So 5 works. But sometimes when you try to do this, there is at least no whole number that works. So if I did the square root of 49, does it have a nice number as an answer? Yeah, 7. But what if I did the square root of 48? No, it doesn't. So 48, do we know about what the number is going to be? Really close to 7, probably like 6.9 or something like that. In fact, we took our calculators. The square root button is right here above the x squared. So, what do I got there? So second square root of 48 is 6.92. Now, if I were simplifying fractions, and I were to simplify, say, 6/3, what does that equal? 2. If I were to simplify, say, 5/15, what does that equal? We can simplify it down to 1/3, or we could write out the decimal, which is 0.333. Okay? And the decimal is kind of hard to work with. We much prefer the fraction, right? So if I go back to the square root of 48, I could write this down, or I could simplify it. Okay? Now, hidden inside 48 is a number that is a perfect square. So 25 is a perfect square. 49 is a perfect square. 48 is not, but hidden inside there is a perfect square. Is there a perfect square that is a factor of 48? What? 6 is not a perfect square. What are the perfect squares? 36? 36 does not go into 48. But you're on the right track. Okay? What are the perfect squares again? Do you remember them? 1. So the perfect squares are 1, 4. Come on, wake up. There we go. 9, 16, 25, 36, 49, 64, 81, 100. Does one of these numbers divide into 48 evenly? 16 does. So I can rewrite 48 as the square root of 16 times the square root of, how many times does it go in? 3. Does that make sense? Well, what is the square root of 16? 4. What's the square root of 3? The square root of 3. So it's 4 times the square root of 3. So if I were to type in 4 square root of 3, it's the same number. Now you might say, why do we care? It's the same number. Well, why do we care which one of those we use? It's more simple for sure. And you might look at 4 root 3 and say, oh, that's less simple. But how many ways are there to write a fraction equivalent to 1/3? An infinite number of ways. So if we were solving a problem, potentially everybody could get a different answer and you could all still be right. Okay? So 1/3, if I say simplify your answer down, everybody will get 1/3. Does that make sense? So how many ways are there to write 4 root 3? An infinite number of ways. So if everybody simplifies it all the way down, everybody will get 4 root 3. And trust me, it makes things much easier when you simplify them. Okay, so let's consider another one. What about square root of 72? Does it have any perfect squares inside of it? This is your time to shine. 36. This is the square root of 36 times the square root of 2. So it's going to be 6 square root 2. Or we just say 6 root 2. If it's a square root, we just say root. Oh, what a good question. Let me do one more, and then we'll get to that. Okay. So what if we had the square root of 150? Does that have any perfect squares inside of it? What's that? 75 is not a perfect square, but you're on the right track. 25. 25 times what is 150? How many quarters make $1.50? 6. So this is equal to the square root of 25 times the square root of 6, or 5 root 6. Now, one of the perfect squares is 81. I don't know my 81 times tables, right? And when we got to 72, what if I said it was, let's see, 4 would go into that. So take it to 18 times. 4 square root of 18. 4 is a perfect square, right? And that would be 2 root 18. Well, 2 root 18 is equivalent to 6 root 2. I just didn't simplify it far enough. It's like saying 12 over 28 is equal to 6 over 14. That's true, but it's not the simplest version. We need to do another 2 and get 3/7. So sometimes you don't know what perfect squares are in there. So there's another way to figure it out. So what we do is we take the number we're looking for, 72, and some of you will prefer to do this every time. What 2 numbers go into 72? So I heard 8 and 9, I heard 36 and 2. They'll both work. 8 is just 2 times 2 times 2, and 9 is just 3 times 3. Now, if a number factored, we can ignore it. So we have developed the prime factors, and for every pair of prime factors, we have a perfect square, right? These multiplied together make 4, 2 times 2. These multiplied together make 9, 3 times 3. So it's kind of like saying the square root of 4 times the square root of 9 times the square root of 2. Does that make sense? So what we do, every time you have a pair, you remove them and you write 1 on the outside. So this allows us to say 2 times. This allows us to say 3 times. That is a leftover. It had no match. Square root of 2, which is 6 root 2. So for every pair, you pull 1 out. Now, it might seem really tricky, but it's actually super easy. So it will. We'll do 36 in just a second. That's a good idea. Right. So let me go back. That's a really good point. So we're not timesing 4 by 9. It's the square root of 4 times the square root of 9. So for every pair, you bring out 1. Does that make sense? So you square root that pair. What is the square root of 2 times 2? 2. Okay, so let's look at the square root of 150. Well, that's 10 and 15, 5 and 2, 5 and 3, and we can forget all of those things that factored. Do we have any pairs? A pair of 5s. So we bring a 5 to the outside, and what's left? So this matched that, and then I have a 2 left over and a 3 left over, which makes 6. 5 square roots of 6. Does that make sense? Okay. What about the square root of 36? We know the answer is 6, but this should still work, right? 6 times 6, 2 times 3, 3 times 2. What can I bring out? Bring out a set of 3s, so I get 3 times. Bring out a set of 2s times what's left. And if nothing is left, it's actually just a what if I pull out all the factors, what factor is left? 1. Not 0. 1. So it's actually times the square root of 1, which is 1. So that answer is 6. Does that make sense? Okay, so what if we did let's do the square root of 24. Six times 4, 3 times 2, 2 times 2, pull out a 2, so 2 square roots of 6. So everybody get that? Or you could look at this and say, oh, 4 is a perfect square. So it's the square root of 4 times the square root of 6, which is 2 root 6. Okay, and so for these smaller numbers, you shouldn't have too much problem doing that. But if you had something like 2400, it's going to be a little bit of a problem. What goes into 2400? 24 and 100. So 24 and 100. So this is 6 times 4, 2 times 3, 2 times 2, and now don't forget, get rid of everything that factored. So here's a set of 2's, and here's a set of 2's. Pull out a set of 5's. So on the outside, I have 2 times 2 times 5. And my leftover is a 6. Does that make sense? So 2 times 2 is 4, times 5 is 20, times the square root of 6. Or 2400 is the square root of 400 times the square root of 6. 400 is a perfect square. It's 20 times 20. Now, I didn't know that to begin with, but because of the answer, I can figure that out. All right. Watch this. What about the square root of 30? What goes into 30? 15 and 2. 3 times 5. What comes out? Nothing. It's like saying simplify 2/5. 2 over 5 is already simplified. It can't go any further. Well, so it's 3 times 5 times 2, but I don't have any pairs. So that one is actually simplified. It doesn't go any further. Does that make sense? Okay. What about this? The square root of, let's say, 108 x to the third y to the sixth. What should we do here? What goes into 108? 9 and 12. Okay. 3 and 3. 4 and 3, 2 and 2. Come on, Abby. Don't lose me. So what can I take out? A 3 and a 2. Now, we also have to consider the variables. This is x times x times x times 6y's. Can I take out any x's? One set of x's. How about y's? 3 sets of y's. So I bring out a 2. Oh boy. How did I ever pass college? Let's try this again. Okay. 3 sets of y's, not a set of 3 y's. Get it right, guys. So 2 times 3 times x, x to the first, right? For every x, for every 2 x's inside, I bring 1 out. So x times y to the third. And then the square root of what's left. So I have a 3 left over, and I have an x left over. So, what's that? The 4 doesn't count because it factored. So 6x y to the third root 3x. Okay? All right. What about 27x to the 7th y to the 10th z? Okay. So I pull out a 3 because of this group. How many x's can I bring out? 3 sets. So y to the, or x to the third. How many y's can I bring out? 5 sets. So, oops, not z. Y to the fifth. How many z's can I bring out? None. Then square root of what's left? 3. We had an extra x. All the y's came out, and a z. Piece of cake, right? Well, now we have to make it harder. What about the third root of 81 x to the 6th y to the 10th? Right, now when we circle groups, it's no longer a group of 2, it's a group of 3. So it's really not any harder. One, 3, so 3. How many groups of x's? 2, for real this time. So x squared. How many groups of y's? 3 with how many left over? 1 left over. So y to the third, and then we have the cubed root. What's left? 3, how many x's? None, and y. Then it would be wrong because it would be the square root, which is different. This, you're talking this 3 here? Yeah, you have to have it. Actually, there is a number inside that. What is it? It's a 2. But it's so common we just never write it. So a square root actually has a 2 in there. A fourth root would have a 4, and so on. Okay, do you guys go into fourth roots? Sixth root. So how would you do the sixth root one? You would have groups of 6. Now, there is one trick. What about the third root of negative 27? Can you square root negative 8? No, why not? And let's, instead of 8, let's do 4. Can you square root negative 4? No, because 2 times 2 is 4, and negative 2 times negative 2 is also 4. Why not 2 times negative 2? That's not the same number. So this doesn't work, at least not today. Later it will work. In the near future it will work. Okay, but are there 3 numbers that multiply to be negative 27? Yes. Why? Right. An odd number of negatives does create a negative. An even number of negatives does not create a negative. So um, if I had the third root of negative 48 x to the 11th, I factor 48, 12 and 4, 3 and 4, 2 and 2, 2 and 2. And we always pull the negative out. Always. So it's going to be negative. Do I have any groups I can pull out? Pull out a group of 2's. So negative 2. Can I pull out any x's? How many sets? 3 sets with 2 left over. So it would be x to the third, the cubed root of what's left. 3's left over, 2's left over, so that's 6. And then I pulled out 9 of the x's, so x to the second. So if the root is odd and there's a negative on the inside, just pull the negative to the outside. Right. And is it true that negative third root of 8 is equal to the third root of negative 8? Well, the third root of 8 is 2. So if the negative's on the outside, 2, or the third root of negative 8 is negative 2, it's the same thing. So because those are equal, we just need some sort of rule to say where to put the negative so everybody gets the same answer. And the rule we've decided is always take it out. The rule could have been always leave it in, and then everybody would still get the same answer. But we've decided if there's a negative on the inside of an odd root, pull it out. Okay? All right. Get to work. Good luck.